Hi everyone, my name is Thomas Kim. Today is 4th of October 2018. This is 17th video about template metaprogramming. In this session, we will learn about the integral constant, bool constant, true type, false type, and we will also learn how to test constantness of C++ expression. To follow this video, please visit this website YouTube video. I will put the link of this video in the description section below. From this video, please download our previous source code because we will use this source code in this session. Show in folder, then unzip it. We will be working in this folder. Copy this folder, paste, then start Visual Studio Code, open folder, select this folder, then enter, select folder. We will create an empty file is constant cpp. We will include iostream, include talk play fun, type name age. We created this file in our previous session. In this session we created this file void test std is const. We create an empty function, then int main, then we call this function test std is const. Then here using type t int we define type alias using c type t constant int using l type int lvalue reference using c l type t constant int lvalue reference using r type t int rvalue reference using cr type t constant int rvalue reference using p type t int pointer using constant p type t int pointer constant. This is constant pointer to int using cp c type t constant int constant. Please note that this is constant pointer to int. This is constant pointer to constant int. We will test this function std cout std bool alpha std cout int is constant. Then talk play fun std is const b type t std, and there, or we can just say int. I will copy this several times, 8 times, 1 2 3 4 5 6 7 8. Then I will change it one by one. Const int reference. Now in the command prompt, cl ehsc std c++17 is const cpp fe out exe. We are using Microsoft compiler. Hit enter. Now out. If we see that int is constant, false. It is not constant. Constant int is constant, true. Okay, it works. Int reference, lvalue reference is constant, false. Constant int lvalue reference is constant. Please note that this is wrong. This is incorrect. And int rvalue reference is constant. This is false. Okay. Int rvalue int is constant. This is constant, but this is false. This is also incorrect. And this integer pointer is constant. False. This okay. in constant integer pointer true, it's okay, it's all okay, but this is wrong, this part is wrong. If you examine the result carefully, you can find that when reference, the type is reference int constant int reference, this should be true, this is constant, but the result is false. Also, when rvalue reference is constant, the result is false, so this is also wrong. When the reference type is reference, constant reference, the result is wrong. We have to fix that. I will mark point here. This is constant and this is wrong, and also this is wrong. We will fix this issue in this session. To understand how this type predicate is implemented, we need to know more about these basic mechanism. We need to understand integral constant, Boolean constant, true type, false type, to understand how this is constant is implemented in standard C++. Template, type name T, var, struct, integral, constant. In standard library, integral constant struct is defined like this, using value type T, using type integral constant, and has one data member, static context sphere T value, or we can say value type value var like this. Context sphere operator value type const no except return value, and another function context sphere value type operator const no except return value. In standard C++ standard template library, there is a data structure called integral constant. It is defined like this way, and also there is type alias called bool constant template bool var using bool integral constant bool var. It is also defined in standard template library using true type bool constant true, using false type bool constant false. So these are defined in standard library. Now we will use this struct to implement is constant type predicate. Template type name T, struct is const false type. Then we have a specialization template type name T, struct is const T true type. And the standard template library also defines type alias using template like this. Template type name T context sphere bool is const, I will say is const B is const T value. This function, type function, is defined in standard library this way, and using this I will copy all this code. I copied and paste it here. I will rename it CST. CST means custom. Now I remove this std part like this, then std cout std, and there test CST is const. Okay, now build out. If you examine, this is false, false, true, true, false, 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 true. These are exactly the same. In standard library, is const b is defined like this, like this way, but this has problem. And if we define two more specialization, this is primary template, this is specialization. If we can define two more specializations like this, I define one more specialization here. In this case, this is lvalue, constant lvalue reference, and another specialization rvalue reference. If standard library defines these two specialization, then build again, then it will be fixed. This integral reference lvalue reference constant is now true. Now it is constant. Also constant rvalue reference is constant. It is true. So these two parts, this is standard library and this is the one we fixed. It works. But since we cannot change standard library, this way of coding is not good, so we have to modify this part. To modify this part, we can remove std, remove reference. If we enclose like this, we change this part and we can comment out this section, and instead we added this part, then it will work. We compile once again, out. So this works exactly as before. So if we want to test constantness of some expression, we have to use this way. We first have to remove reference from type T, then we have to test the constantness. I will change it like this, std. This is standard template library, is defined like this, so we don't need this. Okay, now I will change the name helper like this. Then here we can all change like this, helper, and it should work correctly now, like this. And I will copy this to our library. Copy here. This is our type library file. I will put it here like this. And this is in hide namespace. We will make a macro. I define talk play fun is const. We are providing type instance. Then talk play fun hide is const helper decl type. Once again type. We don't need this two double, we just need one instance. Then we created one macro here, but in some case we want to send the type as well, so I will change it is type constant. In this case we are providing type name, then we don't need have decl type here. So we added two macros. Is type const and is const. In case of is const, we have to provide instance. In case of type const, we are providing type name like this. With this, we can change this line of code like this. Talk play fun is type. Talk play fun is type const. Okay. Now I copied it. Since it is macro, it should be parentheses like this. Now let's build. Okay, it works perfectly. int I equals 0, constant int c equals 1, int reference l I, constant int reference l c int rvalue r5, constant int rvalue reference rcr, I would say cr5, int pointer pi, constant int pci, constant int pointer, constant cpci. Now we create this function, we copy this and modify some code. Now we are calling instance, so it should be talk play fun is const. Here we provide I, and I will copy this part. This is C, this is Li, this is Lc, this is R, this is CR, this is constant point PCI, no, this is PI, this is PCI. We modify this part. C, PI, C, P, I, this is CPCI, C, P, C, I. Now let's build 125, 125. We have to provide I. Okay. Out. Now let's see. It's confusing. We will give std, cout, std, and there. I will put label here I. This is C. This is Li. Constant anti-reference is LC. This is R. This is CR. This is PI. This is CPI. This is CPCI. I will align them. Now let's build. Out. Say this is constant false. This is constant true. This is constant false. This is constant true. This is constant false. This is constant true. So everything works perfectly. This way we can test. Now using this macro and also using this macro, we can test constantness of a C++ expression. Please subscribe to my YouTube channel. Thank you for watching.